So if you take out your highlighter, you can highlight the definition of a trig identity on page 606. So a trig identity is a statement, an equation that has trig ratios in it. That's always true. And we already know some identities. So some identities that we already know are the reciprocal identities. You know that cosecants 1 over sine, secants 1 over cos, cotangents 1 over tan. You know some quotient identities. You know that tan is sine over cos, and cotangent is cos over sine. We can add to these that sine is also 1 over cosecant, cos is 1 over secant, and tan is 1 over cotangent. So those are some identities that we already learned in chapter 6 as part of our big ideas. Do you know another identity that we learned as a big idea that's always true? Sine squared plus cos squared equals 1. So one of the things that we do in this unit, oh yeah, here are the other ones that we wrote up top. One of the things that we do in this unit is we use what we know. So we know these reciprocal identities, we know these quotient identities, we know sine squared plus cos squared equals 1. We use what we know to prove other things are true. And they're sort of like little puzzles. So I'm going to show you the format that we're going to use to solve these little puzzles, and then we're going to work at the first level of the little puzzles. And then we learn some more stuff, and then we get to the next level of the puzzles. Okay, and they get more and more complex as they go along. Just want to highlight one other thing here. Can you see that if you took cosecant equals 1 over sine, and you multiplied both sides by sine, you would get that? And same thing, you could get secant times cos is equal to 1. And you could get cotangent times tangent is equal to 1. So how many different ways can we rearrange identities to make new identities? So this page that I just handed out, at the top it says prove. So in this unit we are going to prove a lot of things. And we need to have a format for how we're going to prove things. So part of what we're going to learn right now is formatting, what we're going to use for our proofs. And what a proof, basically you can think of it as, is a puzzle. It's a puzzle in that you have certain tools, and the tools that you have are right here. You know these reciprocals, you know these quotients, you know sine squared plus cos squared equals 1. With these tools, you have to complete the puzzle to make the puzzle look the same on both sides. So this is what it looks like. Here we have a very simple puzzle. What we're going to do is on a separate piece of paper, we're going to write out the question. And the first thing we're going to do is at the equal sign, we're going to draw a line. Because we want to prove that they're equal, we can't use that they're equal to help us prove that they're equal. So what you're going to be allowed to do is you're going to be allowed to work on the left-hand side, and you're going to be allowed to work on the right-hand side, but you won't be able to move things from one side to the other. And you've solved the puzzle if you can make both sides look the same. So for this puzzle, we've got cos of t, secant of t equals 1. And you think about the tools that you have, and you just say, what's something that I could change? And as you do more and more practice, you'll get smarter at choosing the best thing to change. But what's something you could change on the left side? You could change secant. Secant could change to 1 over cos. So that would be a first step. Now we have two fractions, right? Because this is cos t over 1 times 1 over cos t. How do you multiply fractions? You multiply the top, and you multiply the bottoms. Okay? One of the things you'll probably get, you probably won't even have to multiply these out. You might already see that you could simplify this. That the cos t divided by cos t would cancel out. And what are you left with? 1. You've now solved the puzzle because you made the left side equal to the right side. Because 1 is equal to 1. Now, once we've solved the puzzle, we write a little statement. Therefore, the left side equals the right side. You need to show that you know that they're the same. Okay? If you want to get fancy, I'll show you some of the fancy things I like to put at the end of a proof. That's enough. You could just end with that. But often mathematical proofs have this at the end. That's short form for something in Latin. Any guesses? Question your educational director? Hey, wait a minute. I see what you're saying. No. Quod erat demonstratum, that's probably pronounced terrible, but what it means is what was asked for has been demonstrated. Ooh. So if you want to add that at the end of your proof to make it fancy, I also on my proofs, I like to make like a little box and like shade it fancy. There we go. So I also like to do that at the end of my, something fancy at the end of your proof. Sometimes textbooks have little things, they have the QED or they have a little thing at the end to show that it's done. So I like to make a little square box. If you have your favorite initial and you want to put it in that, whatever you would like to do. So this is a proof, and this proof is done. Now, 6 and 7 are other ones that are really basic and easy. Let's do number. I'll get you to do 6 and 7 on your own. Let's do one more together. Let's do 8 together. So again, we write out the question. We draw a line to make sure that we don't work from one side of the equation to the other. Yes? I know, so confusing, right? You ask someone what the 3 dots mean, and they say they're 4, and you count them again, and you say, no, there's only 3. What does it mean? And then they say, oh, it means therefore. They should have 4 dots. It would be so much easier to think of that. Yes. Identities, and then, well, yes, that does mean something. When something's an identity, sometimes they use 3 lines when they equal in between them instead of 2 to show that it's an identity. But we don't do that. Don't worry about it. Okay. We're going to do number 8. We've rewritten it. We've drawn the line. What can we change? Pick something on the left side or the right side and change it. Secant. What would you like to change secant to? 1 over cos. So now we have those fractions multiplied together. If you wanted to write that as a single fraction, what would you get? Sine x over cos x. Okay. What else can we change? We're not done because the two sides, they're not the same yet. They have to be identical. So yes, you have 2 choices here. Either on the left side, you could write, oh, I know that's equal to tan x, and then I'm done. Or if you, on the right side, said, I know that tan x is equal to sine x over cos x, then you would be done as well. But we need to make the two sides equal to finish the proof. And then we end with our statement. Therefore, the left side is equal to the right side. So they start off not too bad, and I think you have the skills to be able to do all the questions up to 15, 16. So we'll work on those for a bit.